Hello, good morning everybody. I take this opportunity to explain you an important topic in DBMS, concurrency control. We all know the importance of databases. The databases are used for collecting the related information and providing us the up-to-date information for all the users. So the databases need to maintain the up-to-date information. So this is only possible because of a wonderful software called as DBMS. DBMS stands for Database Management System. It is a software which is used to create and maintain the databases. This is a software which helps the database to maintain up-to-date information. When a database is created by DBMS, it provides many number of advantages for the user. One of the striking advantage that is being provided by DBMS is concurrency control. We all know in the current competitive world, the databases need to provide the accurate information within no time. This is the primary motto of any database. So in the process of providing the accurate information, multiple number of users will try to access the data from the database. So thereby a kind of competitive environment will be created among the users to have the same kind of information from the database at the same time. So sometimes this creates a problem at the end of database administrator. The database administrator is forced into a confusion to whom the required information need to be given when multiple number of users try to ask for the same kind of information. So this can be successfully managed by one of the advantage given by DBMS is concurrency control. Concurrency is nothing but providing the necessary information to all different users at the same time without having any problem. So if a user is given with the information, the other competing user will not have any problem in accessing the same information. And moreover, the users who are accessing the information will not be knowing whether this information was already shared by some other user or not. Now, I take this chance to explain you how the concurrency is being maintained by DBMS at different databases. So, I try to introduce a term called as transaction here, and with which we go ahead in understanding the concurrency control in DBMS. So, if you take one example of a bank, each and every bank will have many number of customers, and all those customers will perform many number of transactions. Here, a transaction is nothing but a logical unit which performs some action on the database, either by accessing the data or by writing something into the database. So, as a bank customer, sometimes I try to access the money from my account, or sometimes I try to place the amount into the account. Thereby, I try to perform different kind of actions on the account which was given by the bank. Now, if the same example need to be understood from the point of database, it can be understood from a concept called as a transaction. A transaction is a logical unit either which accesses the existing data or modifies the data or the content which is available with the database. A transaction generally holds two kinds of operations. Either one is a read operation, other one is a write operation. For that matter, on a computer, every user only perform two operations. Either it may be a read operation or it may be a write operation. Read operation will provide you to access the existing data from a database, and write operation is a one which need to be done very much carefully, because if you perform this write operation from the transaction point of view, it should not disturb the existing data which was already available with a database. Therefore, a transaction is a collection of read-write operations. So, if they are not properly performed, there is a chance of receiving the incorrect results. Now, if you observe certain states of a transaction, each and every transaction will come into the force with a state called as active, and it may be, if it do not receive any disturbance, automatically it will be transformed to a state called as committed state. And between active to committed, it will perform a traveling so that it will finish off. And sometimes due to some accidental reasons, the transaction may failed, and thereby it may be aborted for a restart. So these are some of the states which categorically explains how a transaction starts its activeness and how a transaction is aborted due to some accidental reasons, or how a transaction receives the success depending upon the situation. Now, in order to maintain the consistency in a database by a transaction, each and every transaction will contain certain properties. Those properties in database terminology may be termed as ACID properties. So ACID properties are some of the important properties that are possessed by the transaction when they are performed by the user. So a transaction has to contain certain properties, and every user, if they want to perform the transaction, they need to follow these properties. The properties are the first property of a transaction is atomicity. Whenever a transaction comes into active state, either it should be finished completely or it must be aborted. There is no chance for any transaction to be suspended in middle without performing any action. Therefore, a transaction need to contain a property called as atomicity, which either need to be performed entirely or not at all performed. Either it should be completely aborted or it should be finished. Because if a transaction is performed, its action need to be permanently stored in the database. Otherwise, the end users, there is a chance for the end users to receive the incorrect results. So the primary most property of any transaction is atomicity, by which either the transaction need to be performed entirely or it must be stopped entirely. This is the first property of a transaction. The second property is consistency preservation. Whenever a transaction is allowed for performing its action, it should be finished. Whenever a transaction is finished, the database will travel from one state to other state, I mean, I enter as a customer of a bank, I try to perform a transaction on my account. So there I enter into an ATM center and I enter the required password given by bank authorities. Then I try to access the money from my account. Whenever after finishing the drawing of amount from my account, the transaction which I performed need to reflect on my account, because if I have drawn 2000 rupees, the amount which I have drawn need to be deducted, need to be calculated in my account, and it must be updated. So there the property of a transaction speaks that whenever a transaction is performed, its action must be permanently stored. Therefore, if a transaction is performed, it will travel from one location to other location in the database. So there we say that it should take the database from one consistent state to another if the transaction is successfully performed. So the second most property of a transaction is consistency preservation. The third one is isolation. There is one interesting feature that exists between the competing transaction. When different transactions are trying to access the same data, that is being permitted by an advantage called as concurrency. When all the competing transactions simultaneously enter into the database for performing the transaction, enough care need to be taken by the database administrator, because if the care is not taken properly, there is a chance of receiving incorrect results. So once a transaction is allowed, all the remaining other transactions need to be kept aside till the entered transaction completes its execution. Therefore, the remaining transactions need to be isolated. A transaction should appear it is being executed isolated from the transaction. When many transactions are executing concurrently, the execution of transaction should not be interfered by any other transaction while it is under execution. So there will be a competition between the transactions for accessing the data at the same time. but these competing transactions should not interfere with one another. If they are allowed to interfere, there is a great chance of receiving the incorrect results for the end user. So the competition need to be properly managed for receiving the correct results. So third property exactly speaks that the competing transactions should not interfere each other when they are under execution. The last property that is being associated with a transaction is durability of permanence. Whenever a transaction is executed or whenever a transaction is committed in a database, its result must be stored permanently without any failure. So in the process of storing the results, it should not get failed. So the result need to be stored permanently. So these are the four important properties that are need to be associated with a transaction whenever it is given a chance on a database to perform the action. So in a multi-user environment, multiple number of users try to perform different transactions, and all the transactions which are given the permission for the execution at least need to follow any one of these four properties. If any one of the property is not maintained properly, then there is a chance of receiving the incorrect results. When a database is providing inaccurate results for the user, almost it loses its primary objective. We understand that the primary objective of any database is to provide accurate information within no time. If it takes much time in providing the incorrect results, the transaction is not following the ACID properties. So every transaction has to carefully follow the ACID properties for providing the correct results. So each and every transaction will generally provides the correct results by only following a mechanism called as concurrency control. It is the coordination of simultaneous execution of transactions in a multi-processing database. So concurrency need to be controlled in a correct fashion when multiple number of users are trying to access the same kind of data. Here the interesting scenario is when multiple number of users perform an action called as read, there is no problem at all. As I told you, every user is allowed to perform two kinds of operations. Either it may be a read operation or it may be a write operation. If all the different users try to perform the read operation simultaneously, I don't think the database will face any problem from multiple users side. Read operation is a one which provides the existing content without having any disturbance between the competing users. There is a problem, a kind of problem arises when multiple number of users simultaneously either try to perform read, write in combination. So this combination has to be managed or observed carefully. Otherwise, a kind of conflict arises. Because of that conflict, there is a chance of receiving incorrect results. So if the concurrency is not properly managed, if the concurrency is not properly maintained, there is a chance of receiving many kinds of problems. So concurrency control, if it is not fruitfully maintained, there are three problems that may be received by the end users. Those problems are shown in the slide now. They are lost update problem, or the second one is temporary update or dirty read problem. The third one is incorrect summary problem. In computer science, we got one advantage. The title clearly gives us the straightforward meaning whenever we go through the concept. It's not really necessary for any student to by heart the concept given by computer science. The concept title itself to the extent of 50% directly projects the meaning. So here the problems of concurrency are categorized into three. They are the last update problem, the temporary update or dirty read problem. The third one is incorrect summary problem. Now I try to explain you each and every problem of concurrency control if it is not maintained properly. The first problem is the last update problem. So the last update problem, the title clearly explains us the meaning of this problem. This is a generalized problem that we face in our daily life too with regards to banks. This problem occurs when transactions that access the same database items have their operations interleaved in a way that makes the value of same database items incorrect. I mean, let us suppose that there are different transactions like T1, T2, T3, T4, so on, and they are trying to access the data from the database. Now let me explain you how this last update problem arises by taking one example. Let us suppose there are two transactions, transaction A and transaction B, and they have their own operations which are need to be performed simultaneously. Now if you observe this image, transaction A performs at time T1, the transaction T1 reads the value of X. At time T2, the transaction B reads the value of X. At time T3, the value of X is being updated by a transaction called as A. At time T4, the transaction B try to update the value X. Now at time T1, the transaction A reads the value of X. At time T2, the transaction B reads the value of X. At time T3, transaction A try to write the value of X on the basis of the value seen at the time T1. So by looking at the value at a time T1, the transaction A try to write something into the database by changing the value of X. But if you carefully observe at time T4, the transaction B try to write the value of X on the basis of the value seen at a time T2 without actually caring the value of X at a time T3. So the value which was written by a transaction A at T3 is being lost, and T4 try to update a value which was not at all existing in the database. Thereby the transaction B generally receives the incorrect results as it is not carrying the changed value of X by a transaction A. So the updation of transaction A is lost at a time T4 because the transaction B overwrites it without looking at its current value. So this type of problems may be referred as a last problem, as update made by one transaction is lost here. When you this is one clear example really speaks how a updated value is lost before other transactions receives it. So if it is now if the same kind of example is attached with a bank, if customers are receiving incorrect results with regards to their financial information, then that creates a lot of problem at the end of a customer, and they may lose the confidence on the bank which is providing the information to them. After all, it looks very simple from these two transactions A and transaction B. If at all, if the same example is applied for the customers of a bank, then it creates a lot of problem in understanding the confidentiality or in understanding the confidence that is given by a bank. So the last update problem need to be handled properly before actually changing the value from one transaction to other transaction. So the operations between the transactions like A and B need to be interleaved properly. I mean, need to be arranged properly so that this arrangement should not affect the other transaction in receiving the incorrect results. So therefore, at the end, while allowing a transaction for performance, we need to be a bit careful, because the operations that are available with each and every transaction need to be allowed by avoiding the interference of other transactions simultaneously. If this interference is not managed properly, then as we seen, there is a chance of receiving the incorrect result. This is about your last update problem. And the second problem is temporary update problem. This is an interesting scenario where we face in our regular life. We might have seen this example for many a times in our lives, by this time. When we enter into ATM, when we try to draw the money, due to some accidental reason or due to some power failure, before receiving the money from the ATM, the transaction gets failed. But our mobile gives us the information, we have drawn the amount from our account. Then this creates the panicness in the minds of a customer, because in reality we have not drawn the money from ATM, because in the process of receiving the money from that bank, the transaction has got failed because of a power failure. But the failure has not been reflected originally in the database, but the value of our account has been changed and we have received the information from the bank side, and this immediately creates a kind of panicness in the mind of a customer. This is just because of temporary update problem of a database. So this problem occurs when one transaction updates a database item and it's got failed because of some reason. Before actually updating its value in the database, it got failed. So the updated value has been lost and the other user will receive some incorrect results. But the user who has received that result will definitely feels that he has received the correct one, because the end user may not be knowing what actually went there. So this is clearly violation of an isolation property of a asset property of a transaction. So at the starting itself, I told you, whenever a transaction is allowed for its action, definitely it has to follow the asset properties of a transaction. If any one of them misses by chance, then we receive a kind of failure, we receive a kind of incorrectness from the database. So a temporary update problem really creates a panicness in the mind of a user who try to receive the data from a database, because it happens to provide you the information without caring whether the updated information is being given to the user or not. So updation has not been reflected, and before actually reflecting into the original database, the result has been given. So this is nothing but a temporary update problem. This has to be handled carefully, because this is one problem which definitely give 100% inaccurate data to the user if it is not properly handled. The next, now if you look at this slide, this clearly shows how a chance may be taken by transactions called as T1 and T2 in providing the information. Hope here also I am trying to perform two operations called as read and write operation. Read operation, initially I read a value as 35, then I perform some operation by adding 100 to existing 35, then I try to change that value as 135 because I have added 100 to 35, and because of this comes under an uncommitted orientation. Then I try to perform one more operation called as subtraction. I subtract a value 30 from 135, there I get 35. Then the people realized that the earlier updated value was uncommitted, then it was rolled back. But before actually rolling back, the value has changed to 105 because the operations that I have performed are not reflected into the database. This example clearly shows how a database will provide you the incorrect information if the action performed on the database is not updated within the time. So the operations of different transactions need to be allowed properly for their performance. Otherwise, if they are not properly arranged, definitely the competing transactions yields incorrect results. The next slide clearly shows how these operations may be corrected if they are not committed, if it is not committed. So in the slide also I say I use a value 35, then I try to perform the operation, and this slide clearly shows if the operations of different transactions are arranged properly, then there is a chance of avoiding then there is a chance of avoiding or producing the incorrect results to the end users. So this is these two images clearly shows how operations are need to be managed from the competing transactions like T1 and T2 if they are not properly stored or not properly saved in the database. The third interesting problem given by these concurrency control is incorrect summary problem. This problem generally occurs when a transaction calculates some aggregate functions like some count or whatever it is. They are nothing but the aggregate functions or a set of data, while the other transactions go for updation. When one transaction is calculating the values, when one transaction is performing the operations by taking the aggregate functions or a set of data, if other transaction take a chance for performing updation, then a kind of mismatch arises between these two transactions. When one transaction is calculating the values or a set of data by using aggregate functions, if at the same time if somebody like other transaction is trying to update the value, then generally a kind of mismatch arises between the transaction. This yields in providing again the incorrect information to the end users. Thereby the primary objective of database immediately misses. At the starting itself I clearly told you a point. The databases always travel forward in providing accurate information by taking less amount of time. If time and the accuracy, if any one of them are missed, then automatically the database comes under imperfect category. The databases that we have designed are not that suitable for the current situation. So incorrect summary is one problem which always try to decrease the popularity of any database, because multiple transactions are trying to perform their operations without having any perfect control over them. So this some data, if you observe the operation mode in incorrect summary problem, some data may be read after they are changed and some before they are changed. This gives inconsistency in this maintains inconsistency in providing the results to the user, because we as a user we approach the database to receive the correct results at any time. That is the reason I say databases always maintain up-to-date information with the help of a sophisticated software called as DBMS. If incorrect summary problem forces the database to yield inconsistent results to the users, then the database is not perfect enough to manage the operations that are being performed by different kind of transactions. So these are the three problems which really creates a kind of confusion among the transactions if they are not properly. Then a question comes into our mind: how these problems need to be managed. Definitely if the concurrency is not controlled in a perfect order, we face these kind of problems, but the database need to have a solution by maintaining the concurrency correctly. That may be possible by introducing a concept called as a scheduler. We understand a generalized meaning of a scheduler. Scheduler is a one who schedules the operations by maintaining the serializability. So here the scheduler is a program which manages the operations of different transactions to be performed. So here each and every scheduler will maintain the serializability so that no conflict arises between the competing transactions. The transactions who are trying to perform their operations simultaneously should not conflict with each other. The conflict need to be avoided, and this may be done by using a scheduler by following a method called as serializability. So the scheduler takes the responsibility of serializing the operations of different transactions to produce the correct results simultaneously. So for which the scheduler follows different kind of concurrency control algorithms By that, each and every transaction yields consistent results to the end user. So the scheduler is primarily responsible for providing a schedule for each and every transactions to perform their operations. So if operations are not properly performed, I told you a conflict may be arised. So if two different transactions perform read operation, the slide shows that absolutely there is no conflict at all. Already I told you. If two competing transactions like T1 and T2, if they perform read write, a conflict arises. Write read, a conflict arises. Write write, a conflict definitely arises. So the permutations and the combinations for performing read and write operations need to be done properly. So both the read and write, write and read, write and write are not allowed from different transactions called as T1 and T2. If different transactions try to perform read operations simultaneously, we don't have any problem. Then this concurrency control need to be managed in a proper way, as I told you. So they can be done by using different kinds of methods called as locking methods. So concurrency control need to be controlled in a proper fashion by using the methods called as locking methods. So generally a lock will be applied on a transaction if it is under execution, so that the remaining competing transaction will not try to access any kind of information from the locked transaction. So lock, we understand the generalized meaning of a lock. If it is locked, the other user is not allowed to enter. So when different transactions like T1, T2, T3, T4 are participating in the competitive environment for accessing the same information, then a kind of lock and unlock techniques are used for information propagation between them. Because when different transactions try to use the same kind of resources for finishing their execution, then the problem arises. So that problem may be avoided by using the methods called as locking methods. Each and every lock guarantees the exclusive use of a data item in a current transaction, so that the remaining transactions which are in competition need to be kept in mode till the allowed transaction finishes its execution. Then we may get one doubt: who will maintain this lock information about the resources required by different transactions? There will be a program called as lock manager, who is responsible for assigning the permissions or assigning the locks which are required by different transactions for performing their execution. So lock manager will have the complete information about the resources which are either absolutely free or locked by some other transaction. For suppose if different transactions are trying to access the same resource, the lock manager clearly shows whether the intended transaction is free or not. If it is free, then simultaneously, if it is free, immediately it will be assigned to the required transaction. If it is not free, the transaction which asks for the required resource need to be waited in the waiting pool, need to be waited in the queue, let me say waiting queue. So this policy will be governed by a program called as lock manager, who always administrates the availability of the resources required by different transactions. So this locking again may be done at different levels, because databases in our syllabus uses a model called as relational model, which uses a structure called as table for storing the information of both entities and attributes. So here the lock may be applied at different levels. When you something like a lock may be applied completely for a database, so that illegal users are not allowed for accessing the information, and even the competing transactions will be given a healthy environment by avoiding the conflicts. So the locks will be maintained at different levels. So as far as this lock granularity is concerned, the locks may be applied at database level. I mean the entire database may be locked, and even as I told you, the relational model is a collection of tables, and the lock may be applied for table at the level of table. I mean the entire table may be locked, and even a table is a collection of pages, I mean rows and columns. A page may be locked, I mean entire page may be locked here, and or else if you observe a table is a collection of rows and columns, and a row may be locked so that other competing transaction will not have any permission to use the same row, or else it may be even there is a chance for the lock manager to lock a field also, I mean an attribute which represents a column. So the locking level may be applied at any situation depending upon the requirement of the competing transaction. Either the entire database may be locked, or entire table may be locked, an entire page required by a transaction may be sometimes already may be locked, or a row may be locked, or else a field may be locked. And these locks are diagrammatically shown now, depending upon the time and depending upon the competition between the transactions T1 and T2. This slide clearly shows how a locked and unlocked mechanism is being applied over different transactions. So if T1 is given the permission, automatically the lock manager specifies the status as a locked one. Then a transaction which requires the T2, if it requires the same, then it has to wait unless until this locked one becomes unlocked. Locked one becomes unlocked. So there is a competition between the transactions to enter into locked mode or to become unlocked mode. If it is in unlocked mode, if a resource or a page or a field or a table or a database, if it is in unlocked mode, then automatically every transaction is freely allowed. This clearly shows applying of a level at a database level, and this image shows applying a lock at the table level. And this clearly shows applying a lock at the page level. Sometimes we may want to, a transaction may place a request for a page, and then immediately the lock manager will come into the picture, whether the intended or the required page by a transaction is available freely or not. If it is free, then automatically the page is given, and it shows to the other transaction that it is already busy with some other transaction. So this is the way the transactions exchange or changes their position from locked stage to unlocked stage, and again unlocked stage to locked stage. A transaction need to receive, or else a transaction will receive the success if it enters into locked stage, because if it has already entered into the locked stage, it's already under the execution. So always a transaction try to make its status to enter into locked stage, so that the resources are given by lock manager, then it completes its execution. So this is the image which shows the page level lock, and even row level, if required in detail, or if required completely each and every information, even a row can also be locked. Then as I told you, even a field can also be locked by the transaction if it requires. Then there are different locking techniques that may be used by concurrency for managing the competing transactions. One of the method is binary locks. As I am using a word binary, it contains two states. Binary always talks about two states. I mean, it has only two states. One is a locked state, other one is a unlocked states. So this is binary locking technique will try to eliminate the last update problem that we have discussed at the beginning. I mean, the lock is not released until the write statement is completed. So binary locking technique is always try to eliminate the last update problem given by the concurrency if it is not implemented properly. So it contains two states, one is a locked state, other one is a unlocked state. So always the value changes from 0 to 1 and 1 to 0. So every transaction try to change its value from 0 to 1 or 1 to 0 always for receiving the success. Then if you look at this image, it shows how the binary locks will be applied, and the binary locking technique is one of the important technique and easiest technique for avoiding the conflict between the transaction. Now this is a clear example, shows how a conflict may be avoided by using the binary locks. So then there is one more lock called as a shared lock or exclusive lock. So the names again clearly gives us the meaning. Shared lock and exclusive lock. Shared lock, it may be shared between different transactions if they try to perform read operation. And there are certain locking techniques which comes under a category called as exclusive lock, where it maintains locking strategy rigorously. Other when exclusively one transaction is permitted for completing its execution, no other transaction is permitted. The rigorous locking technique is applied so that the competing transactions need to be kept aside. It will guarantee that no other locks will be held if a transaction is given exclusive lock permission. This situation only arises when different transactions will try to compete in the environment. Then shared lock is one of the easiest locking technique. When different users try to perform read operation, that will be shared among the users. Then one interesting method or a technique called as two-phase locking, which always ensures the serializability. So as the name suggests us a clear meaning that this is a technique which will be implemented in phase-wise manner. So it will use two phases. One is a growing phase, the other one is a shrinking phase. So growing phase is a one in which a transaction acquires all the required locks without unlocking any data item. So in this phase, the transaction, if it wants to finishes its execution, it has to acquire all the locks required, all the resources required for finishing its execution. So growing phase always try to acquire the free resources that are required for completion of the execution. And the shrinking phase is exactly opposite to that of a growing phase. No new locks will be applied, all the locked items will be released. So growing and shrinking phase, they work in opposite direction and creates easiest environment to avoid the conflict between the transactions. So two-phase locking technique always ensures the serializability. So they'll serialize the operations of different transactions. With that no conflict arises. This image clearly shows how this two-phase locking protocol is being implemented by concurrency control. So binary locking and two-phase locking, shared locking, exclusive locking, these are some of the locking strategies which are exclusively used by concurrency to manage the competing transactions to provide the results correctly. So this slide clearly shows us how this growing and shrinking phase works in opposite direction. Growing phase always increases its locks by acquiring all the resources. Shrinking phase always releases by locks. But even binary locks, exclusive locks, shared locks, two-phase locks, all these locks are used. There is a dead chance called as a deadlock. So we always need to see that deadlocks should not takes place. Deadlock is one of the worst situation. It should be avoided. So at the end, I say that concurrency need to be implemented correctly so as to receive the correct results. Thank you.